Hello everyone, welcome back to the video. So in our last lecture we have completed the topic of match cases. We have done some examples also to make it more clear, and we have done better match cases. Before that I told you about if else statements, conditional statements, and in this lecture we are going to do loop. What are loops? Basically, if we see in English, loop means something that is running again and again on a loop. Like uh, it is a kind of circle that is running again and again. First one thing, then second, then third, then again first thing, like that. It is going to be the same thing running again and again. But that is what loop means. So it is going to be something like that only, related to that only, from logic to logic flow. From one logic to another logic, it is a flow of logic to logic. A structured journey through loop theory, live coding, real world example applications, and hands on practice designed to learn reporting a repetition into mastery. So, this is what we are going to do in this one lecture. Like, we are going to take some real world examples also to make the things more easier. So why loops rule the world? It basically means that why do we need loops in our Python? First thing is that it is going to make our code more efficient. It is going to increase the efficiency of code. It replaces thousands of repetitive lines with a single and reusable block of code. So it is basically helpful in making a code small and precise and very easy to understand. It is not going to take the repetitive lines. Instead of that, a single reusable block of code will be used. That is how it is making it more efficient. Another one is flexibility. It uses unknown data sets or handle user interaction indefinitely. So it is going to manage all the unknown data sets also. It is going to handle user interactions. And other one is core types. It is having some types, some main types that are going to be used in that. Some main types that are going to be used are for loop, while, and do while. Three types of loops are there basically that we are going to learn, that are for, while, and do while. We say it as for loop, while loop, and do while loop. All of these are used in different scenarios that we will study. That in what scenario, which one loop you should use and which one you should not. So the precision of for. What is the precision of for? Use a for loop when the exact number of repetition is known in advance. Its three-part anatomy keeps interaction tight and predictable. So when to use for loop? For loop is then when you know that how many times your code is going to repeat itself. If like you know that it is going to repeat itself for 3 times or 4 times, then you can use for loop. And if you don't know, then maybe you should use while loop or something else that we'll see in other part. For now, we are studying for loop. So according to this, in for loop, you can use for loop when you know the exact number of repetitions in advance. It is having three parts. The syntax of using for loop is having three parts. We write in three parts. The first thing is condition. First you write the condition, the test before each iteration. Okay, the condition, just like the conditions you put on if else statements, it's the same condition, it's just the condition. Okay, initialization, starting variable, and then you have to start the variable. Okay, uh, let's suppose you are just checking something like this condition only, that if I is a variable, I is less than or is equal to 10. Okay, so now you want all of them to start from the value I equal to 1. You're going to start from I equal to 1, so you are initializing the loop. Okay, so here you initialize the loop. It is going to take value from 1, and then you want it to increment itself. Here you know it is going to stop when it comes to 10. So you want that in here first to check for 1, second is to check for 2. But you don't want to write it again in the check for 2, check for 3. Instead just put I and plus plus. It means that increase the value by 1. See. So it will increase the value by 1 and then check for that. Then if it doesn't match, then increase the value with 1 again. Then it is going to check for that. In this way it is going to use for loops are used. Example, for int I equal to 1, I is less than equal to 10, then I plus plus. It means that it is going to execute exactly 10 times, no more, no less, and it is going to just increase by one, like this. Okay, so this is how you write the code for the syntax. First you wrote 4, then put bracket the integer I is an integer, then equal to 1. You first write the initialization, this part. Then you write the condition. Okay, then you write the increment. Okay, so the power of while and do while. So while and do while are the other loops that we just saw. We saw that there are three types of loops that we use: uh, for loop, while, and do while. So for we did, now we'll do while loop. Why? When is while loop used? It is for pre-test. It is for checking beforehand. Like we have to check something before uh, letting the code run. So here is a while loop pre-test is there. Checks the condition before each iteration, may execute 0 times. So in a for loop you are sure that it is going to match at one point, but in while it is going to check the condition before every iteration, before every of in last one we took the values of I equal to 1 2, so it was just checking like that. But in while it is going to check for 1, then it is going to check for 2, then it is going to check for 3. Just like that it is going to check itself before every one of that. And there is a possibility that it may execute 0 times. But do you know that for loop you know it is going to work at least once, but in while it may not even run even once. Okay, next is do while. Do while is post test. To test after the block. Okay, execute the block at least once. It is going to execute at least once. Why? There is no surety that it is going to run at least once or not. It is written 0 here, but it will run at least once, then checks. First it will execute and then check. Ideal for input validation. If you want to validate something by its input, that you are putting something and then you want it to uh, check that if it is like working on that or not, then do while loop is suggested for that. Sentinel controlled. Process data until a special value, example minus 999, signals the end. So here you have to specify one point like where you want to show that where it should end. You need to show some end for it, that at this point, whenever this point is met in your code, then you should stop it. Stop like putting more values and running it. So you need to just give a an end to it. So building your first loop. Now we'll learn how can we try building our own loop, how to use how to write your own loop in your code. So the first step, there are total three steps given over here. So we are going to take it one by one. Counter loop. So counter loop is write for a write a for loop, then calculate the sum of integers 1 through 100. Input loop set up a value that prompts users while they enter the exit value 0. And a dry run trace variable changes step by step on paper to predict output and catch infinite loops they run. So here we are now going to take see all of these one by one, like counter loop. First, you have to write your first condition. Like you have to write your first for loop. First of all, write the for loop uh, mm, that calculates sum of integer 1 through 100. Um, First of all, you are going to uh, write your loop for loop, and that condition is given here, sum of integers 1 through 100. You are going to write a code for this. Like first of all, you start it from 100, like you give the initialization, then the condition, and then increment. Okay, that you're going to write 1 I plus plus like that. Then input loop, set up a while loop that prompts user until they enter the exit value 0. So you can write a prompt users while until they enter the exit value. In that you need to mention the endpoint, the end value, that after this end value is met, then you can stop running the code. Dry run trace variable changes step by step on paper to predict output and catch infinite loops for them. You can also like try running try writing the syntax and all on paper to make sure that if the logic that you wrote is right or not. So you can just check the code syntax and all. Like basically for logic only write it on paper to check the logic if the logic that we're writing is right or not. Nested loops and logic flow. What are nested loops? Do you know about nesting now? Like nested if, like we did. And nested if that a condition within a condition is known as nested conditional state. So here also it is going to mean the same thing, that if one loop is already there and you want to put another loop inside that only, so that will be nested loop. And logic known here. How nesting works. An inner loop completes all its iterations for every single tick of the outer loop, like rows and columns in a grid. So, an inner loops. First, the inner loop, like first it is going to check for the outer loop that you have put there. If it is meeting that, then it is going to see the inner one loop that you have put inside it as nested loop, and then it is going to run it and check if it is right or not. Use case, journal multiplication tables or grid based patterns. So use case are journal multiplication tables or grid based patterns only. So that would be use case. Watch out for off by one errors and accidental infinite loop triggers in the inner condition. So this was all about nested loops. Automation in action. So this is like a real world example for your loops. So in where are loops used? What is the use of loop and all? So it is going to be there in this one. Robotics. It is used in robotics as it can help in navigating a path until a sensor detects an obstacle or a destination is reached. See, it is the while loop thing that at least you need a end to stop, right? So this is how it is working in robotics, like while loop, right? And the next one is file processing. Use EOF control loops to read a file line by line until no data remains. So it can be used in file processing and maintaining all the data within the files and all. Excuse me. And so it is useful in file processing also. So the other one is UI interactivity. Update graphical elements such as animating a pendulum arm using interval based loops. So in graphical elements also we are using loops. Pendulum arm is like again and again moving. So this is how like it is on a loop. So it is also using the thing. It is its intervals are based on the criteria of loops. From simple to sophisticated data analysis. Scan a string of text to count specific characters or words dynamically. So this is like an example like how it is using itself in uh, some like tech areas, how loops are being used in there, like data analysis. Scan a string of text to count specific characters or words dynamically. So this is an example that how it is being used in data analysis. Okay. And efficiency gains. A 5 line loop replaces a manually written 1,000 line repetitive script. Same result, far less code. So as I told you that it is just helping us in writing this code. Instead of writing I equal to 1, I equal to 2, I equal to 3, a lot of those. You can even put the value of I is equal to I less than equal to 1,000. So it is going to 1,000 again and again and again. And you don't need to write anything else. You need to write only one line code that we just did above. And you need not to write anything else. So it is very easy as it is giving us efficiency. Like if the more long code you are writing, more it is probable to have errors in it. So the less the smaller the code is, you can it is easier for you to find any errors if you made by mistake. So it is easier, basically easier, a lot easier for us. Financial modeling calculate compound interest growth over variable periods until a balance goal is met. So it is like financial modeling calculate. We can just calculate compound interest growth a variable periods continues for period like 5 years, 10 years until like you need a specific amount of balance. So you can check that how much time will it take to have that much balance left with you. So here is how you can check your logic, test your logic if you are making it right or not. Here predict the outcome. Whenever you're writing the code, just predict that what answer will it give. Okay. That is how you can know that how the logic is working and how it is not. Error in identification. Why does the loop with a missing incremental or incorrect condition lead to an infinite loop? So you can identify the error, like you can learn identifying the errors. That is only going to make you better and better. Uh, why does a loop with a missing increment or incorrect condition lead to an infinite loop? You can see whenever the loop is going infinite, why is it going? Why is it making like that? Just question yourself, question your own code that how is it working? Why is it working like that? Question it. Then you can know synthesis while a loop that calculates the pattern. Yeah. So this question is given. You can try yourself on writing a loop that can calculate this pattern. Like you're not going to be given the question directly, like put I equal to this and this and try to run the loop. You need to make the logic on your own. You need to write it on your own, that how it is in the language of our code. Like maybe the thing that you want to write has is having multiplication, and I'm going to put the cross multiplication sign over there. You need to write it in the language of code only, like you need to put star over there. So this is what we are talking about. This is how you need to just write it in the language of coding. Master check. So here is a little quiz. Identify the correct loop type. Processing exactly 15 employee records. So what will this be? As we just read above, in the above slides, we read that whenever you know that how many times it is going to run its exact number, so that loop is going to be for loop. But when you are not certain that how many times it is going to run itself, then it is like while loop or do while like that. Reading an unknown list of sensor readings. Unknown list, like it is going to be too much. So here is an assignment given. You can just read this question. User print and close and multiplication table program. So yeah, yes, first of all, the first thing that you are going to do is taking your input. First, you took the input that you are going to initialize it. Then from where it is going to start. Then nested loops to generate the table. Here nested loops by loops inside loop. So that will be nested loop. So you can generate that also. The challenge would be in relation to read prompt. So there is a challenge also given for you to help you build the logic on your own. Okay. So this is an assignment given to you to help you know. So here more content. By the end of the lecture, students will be able to understand why loops are used, differentiate between for and while loops, use the range function, apply nested loops, understand break, continue, and pass. So over there, only mostly theory part was given. But here I'm going to take like more practical things. First, let's again read it. What is loop? Loop is a programming structure that allows block of code to execute repeatedly until a condition is met or a specific number of times. Okay, without loops, you need to print it again and again like this. Okay, so this is a kind of difference given. Without loops, you have to do like this. And then what loops for I range 5. Range is like till where you want it to be. You want it to go into outcome. For I in range, how many times? 5. Print this. Okay. So advantages I mentioned over here reduces code repetition. Code you need not to repeat the code. It saves your time. It is going to make the code shorter and easier to maintain. Then it improves readability and like you only need to read this much part instead of reading this much part. So this is what it is trying to say over there. um, Types of loops. Python provides two main types of loops. For loop used when the number of iterations is known. Then we know how many times it is going to run. Iterates over a sequence such as list, string, or a range. It is going to work only for list, string, or a range. Okay. While loop used when the number of iterations is unknown. When you do not know that how many times it will run, you only know the condition that you want to meet. So it is then used by continuous executing as long as the condition is true. When it is going to run till it is coming out as true, 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 and it will only stop when the condition comes out to be false, when it is not meeting the specific condition that we have given over there. So for the loop, for loop, here is syntax given for variable in sequence and then statement. Okay, variable in sequence, variable and sequence is and so I in range then 5 current I output is going to come like this. It is still range 5, so 1, 2, 3, 4, 5. It is until 5. It is ranging till 5. Like total number should be 5 and not till 5. Okay. So should we just run it and see? So here I have opened the online compiler for I in range. Let us take it in colon print I. See 0, 1, 2, 3, 4 till 9 it is written over here. So this is what it was showing. Next one is the range function. The range function generates a sequence of number. So it is just going to tell you that that point where you have to stop. That it is the range. Only this much number of output should be given over there. Okay. So like you know that how many times it is going to run. Like for the for loop thing, you need know that how many times it is going to run. So basically it is like that only. Um, time where the number of times you want to stop. This is showing that thing. Range function generates the sequence of numbers output. Then it comes out to be like this. Then there are different types for writing range. First is this range and stop. It is going to come like this thing that we just tried. Then is range start, comma, stop. First you tell where it should start, like the initial value, then its ending value, that where you want it to start. 2, 3, 4, 5, like this. Then in other one you can tell that start, stop, step, like this. 2, 11, 2, 4. Like you want to just skip some numbers in between of 2 and 11. So that is known as step. You are skipping, so you're starting over two numbers like this. You step two with numbers and it came out to be this. For our range, let's just put our initial value to be 2. Let's put it 1. Okay. Then endpoint, let's take it 9. So 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8, 9, 8, 8. Okay, now let us take step. Take step of 3 numbers in between that, in between 1 and 9. 4 and 7 came out. 1, 4 and 7 came out. First number is 1. We stepped after 3 numbers. 2, 3, 4 are skipped. 2, 3 are skipped. 1, 2, 3 are skipped. 4 and 5, 6 are skipped. 7. So this is how stepping is working. Then the while loop is for properly explaining the while loop and the examples and all. This part we will do in the next part of this video. Like I'm making two parts of this video. So just for now I'm going to post this one. Then the other from here. Yeah, the while loop. We are going to start in the next lecture. So that is it for now. Now we will, in next lecture we will just complete the while loop and do while loop properly in depth, and we are also going to just try some examples and run it on the online compiler and try it out. Okay, so that was it for now. I hope you understand that in this one basically I was trying to tell you the difference between the loops, like and a basic idea. At least you got a basic idea. That is it. Like that is what you are expected to learn on the first lecture when you are first time learning something. So you just got a basic idea about it. Now in next lecture you are going to just go move further, and that is how we are going to make it very easy. So thank you so much for watching this video, and that was it for today. Thank you so much. Bye for now.